My name is Jason, and today is Thursday, December 31st, 2020, and I'm just going to discuss a brief analysis of free will. I'm a layman, and I'm just curious what anyone else's thoughts on the matter might be. So leave a comment. If you like the video, please press like, and I'd be happy to engage with anyone on this, just for fun. So if you want, you can leave me a comment or just somehow reply with your definition of free will before watching the video. This is going to be pretty low-level analysis in my opinion. I'm a layman. I don't have much formal education that's that relevant to this. I have some, but not that much. Most of you are going to think this is just really low-level. I'm not trying to be some super high-level analyzer on this particular point. This is just a notion I'd like to get people's feedback on. So if you want to say something, I'd be very happy to hear your thoughts. So my hypothesis is that human experience is essentially deterministic, which is an old view. I don't think it's fully deterministic in a certain sense, but as we'll see later. But this is basically where I come in on the matter. Humans are made of matter, and generally when we look at matter from material science, you just see that matter obeys deterministic laws, and at the very large scales of the universe, this is clearly true in our everyday lives. The way objects behave is deterministic, from general and special relativity on down to Newtonian physics. Quantum physics has allowed us to see that there are elements of reality that are currently fundamentally unpredictable to us. And maybe there's some sort of availability for randomness in the quantum realm. But generally speaking, I suspect we're determined. But let's go on and analyze a little further. Even in your quantum physics models here, we got the Schrödinger equation over here, just an energy equation from quantum physics. What you'll see is that even though in this operator over here, there's an element of unpredictability where a particle will be, it's still a probabilistic function, and the overall outcome is deterministic. These are fundamentally deterministic models. Now, what I wrote down here is there's a caveat. The aggregate behavior of a system is deterministic, but the individual particle, the particle components of that system appear to be random. It depends on what you're talking about as a system, of course, but this is my current understanding of where physics is at. So if you look here, I'm sure many of you are familiar with the double slit experiment or the double slot experiment. This is an old experiment. I know I'm not going to be telling anyone anything that new, but over here you see the particle generator or the particle thrower throwing a bunch of particles. They travel through the slots, and when the particle behaves as a particle and not a wave, it generates this pattern, these two columns against the backdrop. Okay. And we see that here too. Now, when you have the particle, say it's a photon or whatever the particle is, travel through these slots, and it travels as a wave, then you get this pattern. And note that the pattern is symmetrical and regular. You have a bar here that's kind of faint, just like you have a bar here on this side. Then you have a slightly stronger bar here and a slightly stronger bar here. And in the middle you have a very strong single bar. That's because the waves form the most energy against the backdrop in those particular spots. Now, the whole point here is that, for one thing, we can actually we know the conditions under which a single particle will occur versus when it will travel as a wave. We can do that using our detectors. If you set the detector, it will become a particle. If you do not set the detector, it will become a wave. Most of you guys, I'm sure, are familiar with this. This is more complicated than this, of course, and there's a lot of study on wave-particle duality and what really constitutes a detector and what an observer means and all that. But the point being, we know under certain conditions it will form a particle and we will see this particular pattern, right? Or under certain conditions, the other set of conditions, it will form a wave and we will see this pattern. And those are all the conditions that exist. There aren't any other possibilities, as far as anyone can tell. So this, even though it's random at the individual level, where this particle leaves the device appears to be a random fluctuation of quantum behavior, the outcome is still deterministic. You will either get two bars, they will be vertical and they will be the same distance apart and they will look like this, or you will get this, what's called an interference pattern. And all systems are made up of matter. Matter obeys these laws at small levels, so ergo, it's easy to see that there's really no room for non-deterministic outcomes at a larger level. Again, this is stuff most of you guys, I'm sure, know. I'm just pointing out here, you always get the same exact interference pattern if it's a wave. And if it's a particle, you always get the same pattern here. Deterministic. That's deterministic. So the implication, as I said before, aggregate structures of matter that are comprised of multiple particles are deterministic. Their nature is set by the prior conditions of the system. Implication from this is that humans are, in fact, deterministic because we are aggregate structures of matter. This is just a little note on here. I'm not saying this does not imply no free. I'm not saying this implies we do not have free will. For definitional reasons that I'm not going to go into here. I'm not analyzing that here, that's a different subject, but I don't think the fact that if we are determined, that necessarily means that we have no free will. I might be what you would call a compatibilist on that point. So here's one possibility, humans are just deterministic structures. Here's another possibility we're about to go into. I call it an amplification of a random quantum event in making a choice. I'll explain what that means here. Kind of going a little slow. So take a quantum particle and assume it moves randomly, which our current physical models say it does appear to move in a random, unpredictable way. Take the outcome of that movement, compare this outcome to a behavioral choice, and the choice is therefore fundamentally unpredictable even to the agent making the choice because they cannot control the quantum's movement. So what I'm getting at, and I'll show you this a little bit further on here, is that if you have a quantum event in your brain occurring and that somehow gets amplified into a choice you make, your choice was still originating from within inside of you, but that doesn't mean that you had any control over the seminal quantum event. So it may be random, but you're not choosing the outcome of a random event, which of course would be a contradiction, right? Because random means you don't have a choice in the matter, it just occurs. So here's an example of what I was talking about. This is an example of a quantum influence choice generation. Let's say you have a cell, and inside the cell there's two receptors. I'm saying there's a subcellular receptor. It's just a receptor within the cell. And you have a quantum particle. And the way this works is that if the quantum particle goes up in this northward path, it hits the left side of a subcellular receptor. Whereas if it goes down, it hits the right side of a subcellular receptor. If it hits the left side of the subcellular receptor, you will choose to first go to the store and then you will eat dinner. However, if the quantum particle hit the right side of the subcellular receptor, then you will go to the store second and eat dinner first. In other words, there's a microcosm or a conception here that sort of is more comfortable, I think, with most people's vision of what free will means, right? It means that you really have the choice. It's not predictable if you're going to go to the store first and then eat dinner second, or go to the store second and eat dinner first. I think it's a little more comfortable for people to think that their outcome is not predetermined. I don't happen to share that view, but this is one possible model for free will that I think is consistent with the current scientific models we know. So we have the generation of an unpredictable choice from a model that is consistent with quantum physics. And then go a little further, just forget about physical science for a moment and reason through it. What are the possibilities besides randomness and determinism? I don't really see any other possibility. There's only random events or determined events. Now there is something I'm going to talk about here, which is randomness within pre-existing limits, but that's essentially just a hybrid of those two, and you're still stuck in the same kind of conditions. There's your randomness, dice. There's your determinism, a series of dominoes falling, and then random within predetermined limits. What I'm getting at here is that, let's say here's the entity and they have a choice to make. So you have here 1, 2, 3, 4, 5, 6 choices. Each of these individual choices will then lead to another series of choices, and each of those choices will lead to another series of choices that the agent will make. Now, assume that this particular choice here is, let's say all of these up at this most northward decision tree are equal in probability. 1, 2, 3, 4, 5, 6. That's 6. So going down this branch is a 1 in 6 chance, same as rolling a die. Going down this branch is a 1 in 6 chance. Going down any of these branches is a 1 in 6 chance. It's the same thing as rolling a die, and seeing the outcome. In other words, these are random, but there is a predetermined limit. The limit is that these are the only 6 choices you can make, and the randomness is that one of these outcomes is going to be unpredictable. You're still going to choose in that you are going to fire a particle in your brain, and that will eventually be amplified into a behavior, and we call that a choice. Now, the first thing is that, of course, I'm sure this has occurred to most of you by now, these are equal probabilities in this model, right? 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6. But let's say this one was 2 out of 6, and this one was 1 out of 12, and this one was 1 out of 12. So what's that? That's 3 out of 6. And then each of these were 1 out of 6. This is where the elements of personality come in. This is where the elements of tendencies to behave a certain way come in. Your decision on any given day may be fundamentally unpredictable, but this decision path is still going to be more likely than other decision paths. So most days maybe you like to go to the store first and then go eat dinner. But on so many days you're going to end up going to eat dinner first and then go to the store. So your personality is the tendency for there to be a greater probability that you will behave one way rather than another, even though you still engage in alternate behaviors. In other words, probability is basically where our personality is. And in my opinion, there's brain structures that basically have a tendency to amplify certain quantum outcomes over another, and that's where you get personality from. Nevertheless, you're still stuck with, in my view, randomness within determined limits. I can't conceptualize of a different category besides these 3. And I think this is consistent with the science. So for that reason, I tend to view everything we do as random within determined limits. And here I was just trying to illustrate that idea, that there's a given probability for each of these bifurcation events. Maybe not bifurcation, but each of the branching points in the decision tree. So some further questions are, what exactly is free will? Can quantum events be amplified in this way? I mean, is it in fact true, right, that a quantum event could be amplified into a behavior? Or are cells and all the subcellular components that are relevant simply too large for quantum events really to matter that much? It's possible, like we showed way back in one of the previous slides, that the aggregate structures in a cell, which are made of quantum particles, of course, but they're simply too large and they function too much as an aggregate for there to be any quantum influence, as far as I can tell. I think it's a possibility. I'm not familiar enough with the subject to know. If any of y'all know, if any of y'all have examples, I would love to hear any input on this particular matter, and really any matter. So can quantum events be amplified in this way? What are the social implications of free will conceptions and definitions, and is it sufficient to say that I can't conceive of an alternative? Just because I can't conceive of an alternative besides random, determined, and random within determined limits, that doesn't imply, of course, that there is no alternative. I just can't conceive of it. Now, I do think that it's a legitimate limit on the possibilities in this case, but if someone else has a different way of thinking about it, or they want to argue that maybe this is not sufficient ontologically or metaphysically or whatever, I'm open-minded to hearing that. I don't think it can really be taken that seriously, since it seems pretty self-evident to me that these are your only options. So, appreciate everyone listening. Any comments would be great. If you like this sort of stuff, I might put out more content. Pretty boring stuff, I think, to most people. Most people are familiar with all these thoughts. This is very layman type of thinking, but I just like to think about this stuff and interact with people on this subject matter. Appreciate it. Thanks.